then once you run the simulations, how you can present your results. Okay, so the first steps when you open the software, you're going to get to the Create New Project window, and you're going to see a whole bunch of options here. So some of the first things you're going to need to do are choose a name for the database and what type it is. So the common extension that's used is MDB, which represents Mike Urban Database. There is a working mode as well that can save special specifications you make, whether you change the symbology or you want to save a background. That's called an MUP. So it's the extension, it stands for Mike Urban Project. So that's better if you are working on something long term and you want to save everything that you have done and not have to redo it when you open the model every time. So the next piece is you're going to have to decide whether you're working on a collection system or on a water distribution network. And you can see here, there's 2 bullets. You have to decide one when you start the new project. However, you can change this if you have water distribution that you're working on as well, once you've started the model. So this is just for the initial setup. And then the 2 most important pieces are the coordinate system and the units. So just a little bit more information. Like I said, the working mode can either be collection systems or water distribution, and this can be changed. You just need to set something up initially. So the coordinate system is really important, and Mike Urban comes with a bunch of standard coordinate systems, both domestic and international. So if you have a very specific project in California that's under a certain coordinate system, you can load that in as well. Or you can just choose one of the standard, most common used ones. And then for the units, the same thing as well. You need to pick a unit-based system when you start a project. It can be changed later or specified for specific aspects. Here in the US, we commonly have clients that want the output in cubic feet per second for discharge, but also we have clients, if you're doing more pump operations or treatment locations, they might want an MGD, or 1 million gallons a day. So you'll just need to pick one base system when you start. So if any of you have used ArcGIS, you will feel very comfortable with this interface. It's very similar, and it's integrated into the Mike Urban software. So you can see that the workspace is the big space in the middle, and then you'll have a table of contents per se on the left side, which will show all aspects of the model you can check on and off while you're using it. And then at the top and bottom and sides, you can place toolbars that you might want to use. And a lot of them, if you've used ArcGIS, will be familiar, selection-based ones, saving, moving things around. But then there are more specific ones that are more suited to what you want to use for what your specific purpose of the modeling is. So just to show you, at the top of the page, there are a bunch of drop-down menus, and that's where you're going to find all of the editors, all of the settings, things that you might want to customize. So for instance, if you were working on a hydrologic model and needed to edit very specific details about the catchment basins, you might want to add the catchment toolbars if they're not already shown. So to do that, you can go into this menu with the tools and customize which toolbars, and you simply check or uncheck which ones that you want to be displayed. And then you can move them around in the interface up here for easy access. If you're more comfortable using the menus, there are shortcuts as well that can be used. So it really is just user preference. All right, as I mentioned before, background layers are really useful. You can get street level ones, you can get world imagery. It's just really useful when you're building a new network and making sure everything is aligned if it's not all directly imported based on coordinates. So in Mike Urban, we call these layers, and you add the layers in the background. You can turn it off So if you are using GIS-based data to import, that data generally comes with a lot of attributes that already are in the data set. So for instance, you might import the data and it already imports the length of the pipes, the diameters, the ground level, invert levels for the maintenance holes. So all of that will be imported directly into your network. And then if you want to add more data or remove some of the extraneous data, you can do that as well. So the most important step when you start modeling is starting an editing session. The editing session allows you to make changes, and otherwise you can just go through all the menus and look at the data, but it won't save it. So for instance, like if you wanted to go and build some new maintenance holes, you would go into the mouse menu, nodes and structures, and you'll see that all of these editors will be grayed out if you are not in an editing session. So you'll see on the top toolbar there's a blue arrow here, and that's how you start it. So if you're working with the network and you're building something new and you want to save what you've done, there's a button here that's called Save Edits. And once you hit this, you can't undo what was just done. So maybe it's good to remember if you've done something that you want to change, you can just stop editing before you save it, and there'll be a window that asks you, do you want to save the edits? So just good to remember that periodically you want to save as you're working. There's not an automatic save. And if you want to go back, once you hit this button, you can't go back before that point. So I was saying before, there are shortcuts also to the editors, if that's easier for you to remember or use when you're using the software. But this is a good view of the main editors that are used. So you have nodes and structures, pipes and canals, weirs, orifices, stormwater inlets, pumps, valves, and emptying storage nodes. Those are the hydraulic pieces. And as you'll see here, we have the hydrology, the catchments, parameters, any tools that you want to edit the hydrology. Here we have boundary conditions, such as rainfall, evapotranspiration, any other kind of weather. And repetitive profiles means adding in the diurnal patterns of the use of the network, cyclic profiles, and we'll get into all of these things. In addition, if you're looking at water quality or controlling pump operations or valves or orifices, that's where you're going to find down here in control and water quality. And then there are some other curves down here if you want to edit catchment basins or storage basins or pump curves or loading points. All of those things are in this bottom section of the main mouse menu. So this is going to be the most common menu that you will be using. Okay, so if you had a blank slate and you didn't just import the data already from GIS or another source, the first thing that you have to do is click on this pencil on the toolbar, and it's called the Create feature. So how this works is once you activate this button, there's a drop-down menu that selects which part of the network you're working on. So for instance, if you're working on inserting maintenance holes, you'll go to the mouse manholes layer and make sure that's shown, and then click this tool, and that'll allow you to draw the manholes in the network. So it's pretty straightforward, where you just click on the map where you want them. You can move them once they're placed. So you just click and it creates a point, and that's exactly what'll happen there. So the nodes are pretty straightforward. The links, so the pipes, you want to connect your nodes, and this time you will hover the mouse over one of the first points, and it will change to green, and that's how you know that it's attached to that manhole. And then you will drag it to the next manhole or the ending point, wherever you want it to be, and it'll turn green again, and then you'll double click. And with the pipes, you're going to need to hit the escape key or right click and exit to stop drawing. So if you don't want to just connect, if you're following a sewer network, for example, and there's just a curve but not another manhole in the network, you can just click once and it'll create a vertex point. And say that the data is off by a little bit, off the coordinate system, you can edit these lines. You can move any of the pieces of the network that you've drawn, and there's an editing mode, and you'll be able to move the pipes around to fit, to align it better with the network if necessary, if you're not using a background layer. Okay, here's an example of one of the editors. So this is for the nodes, and you'll see there's a lot of information here just for each individual node. So the things that don't have an asterisk have to be filled in, or else the network will not be complete, and it'll give you an error. So here you can see there's everything from the node ID. You have to label it somehow. You have to enter what type of node it is. So storage basins are included in nodes. You have to include the diameter, the ground level, and the bottom level. In addition, you'll see here the cover type, normal, spilling, or sealed are the options there. And over on these other tabs, if you have soakaway nodes or overland flow or head loss, you need to specify that as well. So the easiest way to edit is to type right in the boxes. However, if you can also edit in the table here, and you'll notice this little arrow. Let's see if I can get a pointer. So you'll see there's an arrow here. So this means that this node, 152T, and you can see up here that matches, that is the one that's selected currently. You can highlight or create selection files if you're working on a bunch of nodes. If you say you need to increase the diameter of several nodes at the same time, you can select them down here and go to advanced and click show selected, and then you're just working with the ones you've selected. So right now, this is a list of all of the nodes in the network, which can sometimes be confusing if you need to specify just work on a few of them. You can also add in additional information, which can be really useful in larger networks. So what type of network it is. Is it a combined network? Is it a standard network? Any kind of status, any kind of information on the source of where you got the data, and also the coordinates, the specific coordinates will come in. There's also a box for a description if you have to make a specific note about it. All of these things are useful when you're working with larger networks. Okay, so I mentioned before, there's an editor called Curves and Relations, and this is the editor that you're going to use if you need to define a storage basin or a pump capacity curve or any kind of pipe regulation. So for instance, you know that a pipe in a network isn't being used right now. Instead of just deleting it out, you can add a regulation to it here where it can be turned off in a certain capacity either, or minimized flow, or any way that you need to define it. So this is where you will do those kind of regulations. The capacity curves, you can see you have many options for that, just QH, QDH, depending on what kind of pumps you are using. And the basin geometry is pretty straightforward. So you'll have to define the elevation, so at different levels, the cross-sectional area, and the surface area. So when you enter these data, you're going to enter them in the box here, and you can add new lines and delete them or rearrange them. And one of the best things to do is to graph it and make sure it makes sense, or if you already have pump curves that you're following, to make sure that everything matches. So you have that option here when you can graph it. Okay, diurnal patterns are essential for the hydraulic network. So a diurnal pattern is a series of multipliers, and these are going to be the factors that are applied to a baseline demand or a concentration or, for instance, a storage tank water level. So a typical duration is for 1 day, so 24 hours, and you can see here in the editor that it goes from 12 a.m. to 11 p.m. And then you can see the multiplier in the third column. So this is an example of the graph. You can see the peak hours and how it looks for this curve specifically. Now this is going to change for the weekday or the weekend, most likely, as the demand changes and water usage. This is where you can edit it. And if it doesn't have to be exactly 24 hours, but you'll have some pretty complicated math going on and it'll repeat. So typically you see it for 24 hours. And then these are combined, the diurnal pattern is combined with what we call a cyclic profile. So in this editor, so these combine multiple diurnal patterns or diurnal profiles into an entire pattern. So here is where you're going to specify, this is the pattern that's used for a weekday. This is the one used for the weekend. And you may have the same pattern for every day, for every node in your network, or there might be different patterns based on water usage, depending on how the network is laid out and the population. So you can attach specific patterns to specific nodes, or you can apply it to all of them. This is the usage of the entire network. And most commonly you'll see it's linear interpolation for this type of network. Down here, it's important, you'll see a profiles calendar. So this is important for defining which days the profile is going to be used. And for instance, a lot of simulations take place over holidays, and the usage on holidays is not the same as every day. So you might want to create a specific usage pattern for Christmas Day, Thanksgiving, any kind of holidays that you don't want to include because the water usage is different and it'll have an impact on the network overall. So you have the option to define special days or which days of the week and months of the year the patterns are going to be applied to. Okay, so now that we've covered most of the hydraulic elements, we're going to talk a little bit about hydrology. So catchments are essential for any hydrological model, and they're represented here. A familiar term, if you're familiar with GIS, is polygons. So here you can see the catchment is just this outline here surrounding the hydraulic network. Again, it's useful to use background layers, but if not, you can just draw them free form, and you can always edit the shapes. And the tool sets, you'll see there's two specific ones. This one is for editing the physical attribute. The top one is for the physical attributes of the catchment here. And then this bottom one is for the hydrological properties. So there are two separate menus and editors that you will use for these. You're also able to split this into tinier catchments. So maybe this node here has its own sub-catchment basin that's separated from the rest of the network. You're able to split them, to append them, and dissolve them if you don't need them. So there are a lot of tools available to the user with respect to the catchment basins. So the most important piece of the hydrological model is attaching these catchments once they receive their precipitation to the actual hydraulic network. And there is a great tool in MikeGurban called the Connection Wizard. So this tool allows the user to decide how that they want it to automatically connect. And everything can be edited by the user themselves if they want to, or if you want to physically attach them yourselves. However, this automatically does it for the user. So for instance, if you drew new catchments in, and you could just go to this wizard and select the nearest node, it will automatically connect. You can see these lines here. It'll automatically create connections from that catchment to the closest node, or the closest pipe, or any other of these options here. And this brings us to the actual hydrology of the catchments. So the user can define the catchment hydrology and the physical attributes in this catchments editor. And you'll see that there are two tabs here. This is important. So the geometry or the physical attributes, and this is the hydrological properties. So on the second tab, you can see the most important is to decide which hydrological method you want to use for the computations. And you can see there are a bunch of methods here. Everything from time area to kinematic wave or the unit hydrograph if you're going that way. So the most important properties of a hydrology are the parameter sets, which includes infiltration, initial losses, the impervious and pervious values, Manning numbers, or additional wastewater flows you'll see here. Mike Urban does come with standard default values if you don't have specifics on this information, but you want to add the catchment hydrology into your model. So there are standard values. It'll be called default. However, this is where you will edit all of those things. So one of the most important pieces is adding the meteorology. So the rainfall runoff model, meaning the hydrology, it's important to add these features in. So these are specific external boundary conditions that are loaded into the model. And again, you're going to have to name it something that's very specific, which type. And the most important part is how it's going to be connected to the network. So there are three options here. It can be connected to a single catchment. You'll see here this one says individual. And then down here, you're going to need to connect it specifically. And you'll see the three dots right here. So if you choose this, if you click on this, it'll bring you to an entire list or bring up the network itself. So you can physically click on the one you want, or you have the option of selecting which one by typing it in. Another option is there might be, you'll see here, it'll say list. You'll see a list here. So you'll create an external list and attach it here, and it'll distribute it according to that based on how it's set up. So it'll create a list of nodes to distribute that to. And then finally, a lot of times, if you don't have specifics about the hydrology, the third option is all, and that will be applied to the entire network, all the same. So, if you don't have mountains or other aspects of the physical topography, you might want to just apply it to all of them the same way. But there are lots of options in there. So there are several ways you can attach these files. You might have data in different formats, but one of the most common things that we have our own proprietary format called a DFS0 file. And essentially, this is a file that looks very similar to an Excel file that you will attach, and then Mike Urban will read that specifically. Okay. Now that you've set up all of the pieces of the model, we're ready to simulate it. So the most important thing to remember is that when you're running a model in Mike Urban and you want to attach the hydrology, you're concerned with both the hydrology and the hydraulics, is that it's going to be two separate simulations. So first, you're going to run the hydrology and the hydrodynamics, and then you're going to attach this as a boundary condition when you run the hydraulic network. So it's really important that you run the hydrology first, and then you add it when you run the hydraulic network. So in order to run a simulation, there's a menu that says simulation, run mouse, or there's a button that just looks like a blue play button, and that's the easiest way to get to the computation window. So this is what it's going to look like. It's a little overwhelming at first. There'll be 4 tabs, but it's straightforward once you learn how to use it. So the 4 tabs are general settings, runoff parameters, network parameters, and network summary. So you'll see that you're going to put in a simulation ID here, and you can enter a description if you want. So this ID will be shown on all 4 of the tabs when you click over once you type one in. And again, just like all of the editors, you can see this one with the arrow, you can highlight. This is the one that's active right now. So here you have to decide whether you're running the runoff model, the hydrology, or you're running the network, the hydraulic model. So you have the option right there. And then you're going to need to fill in the simulation period. So for instance, this one runs for 2 weeks. You can also, if you have rainfall files loaded that have a specific date and you want to run it for the entire time period, you can hit set max time, and that'll automatically update this to the files that have been loaded. If one of the rainfall files does not extend to the time you want to simulate, you'll get an error. So only the period that you have defined in the boundary conditions can be run. So if you're getting an error in simulation, that's always good to check. And then you'll see right here, I'll talk about this a little bit later, but the simulation type, Mouse is the standard engine. Mike 1D is one of the newer engines with a multi-core. So you have an option there, which type that you want to run. Okay. For the hydrological rainfall runoff models, you need to decide which type you're going to run. So there's 2 distinct classes. You have the surface runoff model, which is the most common type, but only surface runoff is computed in those. Or you have a continuous hydrological model where the precipitation balance is truncated or is not truncated, and it's running a continuous model. And this includes both overland and subsurface components. So for instance, if you were running a kinematic B with RDI, that would be continuous. So you're going to find all of these attributes on the runoff parameters tab, and you have to decide which model type and the simulation time step. So if you run the model, so say you fill in this information and you hit, go back to the previous page, and you are hitting a runoff type here, and you hit start simulation, and then you get an error. You'll receive an HTML format file, and it'll tell you fairly specifically where the error is, and that allows you to check in the model. There's also a tool available called the Project Check tool, which you can specify if you want to check any piece of the network or the entire thing. Before you run simulations, this is always a good option, and that allows you to see what errors could possibly occur. It's a really good tool to use if you're a brand new user. Once you run the simulation successfully, you're going to get a summary report, also in HTML format. You can save this or specifically in whatever format you want, but it also gets saved in the project directory automatically, so for future reference. It's important if you are running a model multiple times and you want to compare errors or summaries that you switch the simulation ID to a new thing, because otherwise it can get overwritten. And then when you run the runoff simulation, you're going to get a result file with the extension CRF, which stands for Catchment Result File. So this is automatically loaded into the memory as well. And this is what we're going to use as a boundary condition for the hydraulic network simulation. Okay, for the hydraulic, we're going to refer to the Network Parameters tab, which is the 3rd one over. And again, you see the simulation ID. Here you're going to see the simulation mode, which is normal for most of the time, unless you're running long-term simulations, and then you will check this, and it'll ask for additional files. So like I just said, this is where you will input that CRF file. You will check the runoff, and you will search for it in your directory. So you'll hit the ... and you'll find that CRF file, and it'll load it right here. You also need to decide what type of model you're running and the time steps, and how often you want the program to save it. So this is important depending on how much memory your computer has and how quickly and specific you want the results from the simulation. If you have any control or additional parameters that you want to include, this is where those are. RTC stands for real-time control, so that would be pump activation, valve, orifice, closure, opening, those kind of controls. You will check this box, so it'll consider those. If you're doing water quality, you have two options for pollutants and sediments here. So those will be added in there. And then here, you have an option for the results. So it's standard is mostly what you'll use. Like I said, it will overwrite it, so you don't have a million files to deal with. But if you want to save changes, then you will just name it something else and not overwrite it. One other feature that's really useful if you have a larger model is the hot start. So if you want to warm up the system per se, so that you're not just starting from a completely empty system, you can use this hot start feature. And so you will run a very specific model first for a few days, a week, something like that. And then you will load that in as a hot start file. And you just need to make sure that the dates align with the end of the hot start matches these dates aligned with on the general tab when you want to run the simulation. So that's a really useful feature for longer simulations and more complex models. So now that all of your simulations have worked properly and you have the results, you're going to want to present them. So there's a lot of options here. You can load them directly into MikeUrban. You can create plots and animations, which are really useful. You can compare different results for parts of the network, or you can create statistical analyses and see what's going on through symbology or technical printouts. So one of the most common uses here is you want to compare the meter data with the model data and make sure it matches up from the water meters that are in the network. So the first thing is you will see there's a results manager. And because the results are automatically saved, when you run them, you'll see in the result manager, for instance, here we have the catchment runoff file, result file, and then you have the hydraulic network, which has the extension PRF. So you'll see you have this first simulation represents the hydrology, and the second one represents the hydraulic network. So in this results manager, you have the option of removing extraneous simulations. For instance, you ran it 5 times and you only are interested in your second simulation. So you can just highlight them and remove them. And that just is a good way to make sure you're in the right scenario simulation that you just ran. So if you want to physically see the results, you will load them into the model network, and you can create time series. So say you want to specifically see what the water level is in a specific node in the network. You can either access this through the model results open time series menu, or there's a button that looks just like a plot of 2 lines here that you can click on. So when you click on this, you're going to get this box called the result selection. And again, you're going to have a drop down of multiple options. So if you're looking at this simulation 2, and then which type of data you're looking at. So we're interested in water level. Other options would be pipe discharge, pump discharge, etc. So if you want to physically select it in the network, you'll just click OK. And you can see here in this photo, when you hover over the nodes, they turn, you'll see a little cursor show up here. And that's how you know that you can select that item. If you didn't want to do that, or you knew which 5 nodes you wanted to look at, you could check list, and then it'll bring up another window with a list of all of the nodes in the network. You can select which ones you want, and then it'll bring up multiple graphs for those. So this graph here, if you selected one of the nodes in the network, you're going to see it shows which node. It shows the data in sort of an Excel format of the timestamp, and if you slide this over, it'll have the physical value. And then the most useful thing is to see what's happening at that node in your simulation. So you see here, and the water level increases, most likely for a marine event, and then decreases again. And then you'll see here, this is more the standard dry weather flow pattern going back as the water in the network settles. So these are really useful to use as presenting results and seeing what's going on. And say you want to see what's going on in a certain section of your network. So initially, it just looks like this, but say you want to see what's going on between node 1 and the storage basin or the outlet. So there's an option to draw these status flags, and you'll see here they look like blue flags. You can also access them through model results, profile, plot, and define the path. So what you're going to do is just click on the node where you want it to start, and then click it. You can click multiple times, but the main point is that you need to make sure that the program understands which path you're following. So that's what it means here by make sure it's not an unambiguous path. And then you just, you'll see that the flags, when you click them in the network, they're going to have little numbers associated with them. So this will say flag 1, and this will say flag 2. So that's the way that the profile is going to be drawn. And then after that, you click Create Profile Plot, and this is what you're going to see. It's drawing a side view of the model network. So not only do you get the slope and pipe diameter, but you can also see the animation of how the network is operating. You can see, if you have flooded manholes, you'll see the water level can get up to here. And you'll notice that those are, maybe you need to put a siphon in the network or some other option to prevent the flooding there or change the manhole type. So this is a really useful tool, and you can step through quickly as a full animation, more like a movie, or you can do a step-by-step step through, and so you can find the specific point where the network is flooding or there's no flow through the system. It's really good for analysis and troubleshooting in problematic parts of the network to physically see it. This is also really useful if a lot of times you get errors when you're first building a network that maybe you didn't get the correct invert levels or ground levels, and the pipes are offset from the one precursing it, and the manhole levels. So you might see physical disconnects in the network, which will come up as errors, but this is a really great way to view it. Instead of just looking through the tables, you can physically see that they're misaligned and correct it. So another option, if you are more interested in, for instance, flood zones, is really common. You can add specific result layers to the map, and just like you saw in the table of contents before, they'll be added there, and you can check them on and off depending. So you can add multiple result layers if you want to. So in this example, it's coming from this result file, and you want to look at the link discharge. So what you see here is you will set, I'll talk about this in a second, but you can set the symbology to certain levels. So if you have, if it surpasses a certain discharge rate, that's considered flooding or too fast or whatever other details you're interested in, and then they'll color code it in the network. So maybe the area of interest here is this teal area right before the storage basin. This is obviously a different level than the one coming in and the one going out. So maybe that's a problem area that you want to focus on. And the best part is that you can animate this just like you could with the profile plots. So you can run it through the entire simulation period step by step or as a whole and see what's happening and changing in the network and at the exact time that things are happening. So it's very, very useful. And so this is how you're going to do it if you want to do statistics. So there is a specific menu called Result Statistics. And again, you're going to choose which file it's coming from. And for instance, you might want to find the areas of max node water level or max discharge. So you'll just check whatever boxes that you want and you'll hit calculate. And then these are added as the result layers. As I was just saying, you can see them in the table of contents. They'll be listed right at the top. And this you can define in the symbology. If you're familiar with GIS, you can change the graduated colors or symbols and define specific values. And then this translates directly to the network. So you can see here that the red areas are much higher discharge rate than the blue areas. So there's a lot of flow in these areas, specifically around pumping stations or other areas, storage basins. This is a good way to physically see what's happening in the network. And again, you can add multiple ones and check them on and off depending. Okay, so that brings us to the end of the overview of the network and starting a model, running through, building it from start to finish. I see that there's a bunch of chats, so why don't I look at those quickly before I go to the few final slides. Let me see. Okay, the first question looks like it's regarding EPA SWIM, and yes, it is compatible. So if I go back to the beginning, so you'll see right here when you start a model, and again, it's an option in the menus once you've already started. So you can check if you're looking at SWIM. And the standard is mouse. You can add SWIM very easily. It's just a checkbox. So those will allow you to add in all those features that you have. So it is compatible. Regarding a trial version, I'm not sure. I will have to get back to you on that. And it can simulate 2D options. Find that slide. So when you go to the model simulations, here, you'll see there's an option for 2D Oberlin flow. And I'll get a little bit more into this in a minute, but our new software that we are just bringing out, which I'll introduce in a second, is more compatible with flood and stormwater control, and it definitely has the flood built right into it. Okay, there's a question regarding the time steps for simulation. That's a really good question. There are standard ones that are already put in there. Let me see if I can find it. Yeah, there are standard ones that Mike Urban has. I believe the standard is 1 minute min, 60-minute max, and a factor. I think this is the standard 1.3. It's a little bit of trial and error depending on your model. If you choose larger time steps, it's going to be less in depth in your results, but depending on what you're focusing on, if you have a very, very specific instance that you're looking at and you want to see how a rainfall event of 3 days responds, I would recommend doing a specific model just for that over, the course of an entire season, and then you can get a very specific time step and a very intricate look at what's happening. If you're modeling for even 2 weeks or longer, I would do a pretty large time step. It won't have a huge impact on the results. And the saving also has a big impact. So if you're saving it every 60 seconds versus saving it every 5 minutes, that has a big impact on how long the simulations take. There's a question about the hydrology tab. So there's a bunch of options there. So for the catchment basin specifically, it's going to be in the menu that's called, under the mouse menu, you're going to see catchments and catchment parameters. That is where you will come up with this editor where it says catchment space. And then there are 2 tabs there. One is the geometry and one is the hydrology. And then from here, if you wanted to see, I think it's on the previous slide. This slide. So one of the toolbars you'll see here, these are the specific hydrological parameters. So the letters are associated with which type of model you're running. For instance, this is kinematic wave B, and this is time area step A. And then again, you see this symbol, which will bring up that catchments editor in both places. So this is the physical attributes of the catchment. So splitting them, appending them, changing their physical properties. And then these are associated with the hydrological parameters of infiltration, all the things that you see there, so manning number, all of those other aspects. Okay, Haley. Okay, data import. So there is an option, another wizard, that's the data import wizard, and you can import any kind of data you want. And the good aspect of that is it's a little more complex for this intro webinar. but you can import shapefile data, you can import XML files, Urban is in an Access database, and that is where you will find all the links for where the tables and editors are coming from. So in there you can trace the path to which specific attributes you want. You can edit it in there, which is a lot of times easier if you're doing mass changes. And that's where you will edit the data and import it from. So if you have questions specifically about the import wizard and importing data, feel free to contact me and we can go through that together. I think that's it, the questions. So let me continue on. And I know we're about 8 minutes from the end, so if anyone is short on time, thank you for joining us today. And I would like to take a few minutes to introduce our brand new cloud-based software. So this is going to be the successor of MikeUrban. It's called MikeUrban Plus. And it's very exciting for those of you who are interested in continuing with urban modeling. So this comes with all of the same options that MikeUrban does now. So it's collection system, water distribution, and the 2D flood modeling built right in. So it's less dependent on the GIS, and it is based on other cloud-based software, so ArcGIS Pro, for instance, and it's a lot more flexible for what users need. So this is what it looks like. It looks very similar to what it does now, except it'll be on the cloud. So it'll be a cloud-based interface. And you can see still have the table of contents here. You still have the information down here, and you'll see there's different tabs now for the results. Everything is just a lot more accessible. There are fewer menus here, which simplifies things. And instead, the data is going to be shown in multiple tabs. So you don't have to keep opening editors. You can just keep up the nodes editor here and go to different tabs when you're using it, which makes things easier. And then when you click on whatever tab, you'll have different toolbars available for whatever you're doing in the network. Here you'll see information that's listed. You can move this window. There is the option for the information window now in MikeUrban, but it can't dock to one of the sides or the bottom. So you have to keep opening it if you want it, or put it in the background, which can sometimes get in the way. So this is great that you can see everything right here. And then you have a lot of the familiar options, and the interface is very similar to what it is now. So it'll be a very quick transition if you are familiar with using the software already. So some of the improvements that you'll see specifically to wastewater and stormwater is a lot more management with reducing SSOs and CSOs and emergency response for flooding. It also helps you, if you're interested in the stormwater sector, there's best management practices and low impact design options for green cities and sustainability options. And you still have the options to design and optimize the real-time controls, which is a very, very common feature that users are interested in. And it still has long-term simulations and RDI. And it also has the control with, a common problem is the buildup of sulfide gas in pipes. And so you can actually assess and control this now as well. So for the most common features and improvements for the water distribution side are going to be the pressure zone mapping, flushing analysis, and multi-source tracing. It still has the, as I said, the real-time control and water quality pieces, but now there's going to be fire flow analysis and pressure dependent demand analysis as well. Here you can see the interface is a little more detailed. We have a web-based app called the DHI WaterNet Advisor that is really popular and easy to use. And so if you have seen this or are familiar with this, this is just a larger version. So you can see everything is just more flexible and specific. You get a much more detailed view. And now you can analyze the pipe criticality and valve criticality. There are a lot more pieces for sustainability And you can also run cost analyses, which is great. So as I mentioned before, in the simulation window, the common engine that we're using now is called Mouse. There is a new engine that is a multi-core processing, and it's called Mike1D. So all of the new software will have the Mike1D engine, which leads to faster simulations and a separation. If you wanted to run, for now, you have to run, as I said, you have to run the hydrology, and then you have to run the hydraulic piece for simulations. So in MikeUrban Plus, you now have the option to either run them separately or run them combined. So you don't actually have to run two separate simulations and load in the result file. You'll be able to do that simultaneously if you check the boxes to do so. There's also gridded rain for radar, and you can run the runoff for each sub-catchment individually. So if you're looking at very specific catchment basins and how they react differently to one storm event, that's really useful. There's a new storm quality module, which includes more for sediment and pollution buildup and wash off, which is really important if you're interested in water quality. And you'll see here, there's more intricate views of what's happening with the real-time control or sediment transport. Someone asked about the long-term simulation. So it is very complicated, and this improved MikeUrban Plus has the option for defining that specific events in a way that's more useful and doesn't crash modeling. Yeah, it'll be treated as a standard output, meaning that you can check that, and it'll be less complications with long-term simulations if you're interested in that. But overall, there's just more intricate outputs and what's happening for your operations from an operations standpoint. So right now we're on track to release this mid-year this year. So it's very close to the release date. And if you are interested in the new software, these are two of our best people to contact for the United States. Colin Roberts is the Director of Sales and Business Development, and his email is cjr@dhigroup.com. And then Josh Mendez is a Technical Sales Associate and Modeler, and he is jme@dhigroup.com. But please feel free to reach out to me as well if you're interested. So I think that wraps up everything. I will take a look at the chat window one more time for questions. Here is my contact information if you have additional questions or would like more information on MikeUrban or MikeUrban Plus. I'll be happy to reach out and help you. And just take a look at the questions. Okay, there's a question about preparing and importing a background image. So let me go back to the interface here. So you'll see if you've ever used GIS, it's the same symbol. It looks like a yellow square, and there's a plus sign in it. So that is how you add layers, specifically background layers. So just like in GIS, you'll have the option once you click on that to add a specific layer or direct to a layer that you have on your computer. So it is that simple, and you'll just direct where it is, and it'll load in the background. And then in the table of contents, it will show up, and you can check it or uncheck it depending. A recommendation I have, if it's a very intricate world imagery or something from satellite, that when you're zooming to different parts of the network, I would turn the layer off just for making it faster when you're moving around, and then turning it back on when you're in a very specific area. So the difference between Mouse and SWIM is Mouse is our software engine, and a SWIM engine has to do with EPA. it's a specific tie-in to EPA and EPA Net. So EPA Swim is more, it's a little simpler. So, but if you already have models there, it's good to import the data from that right into it's compatible with our software, so it'll import directly. For the rainfall, you can set up how often you want that to be attached.
Joanna, I think we lost you. We can't hear you.